Okay, guys, looking at number 6 here. We finished 5 on Friday. We're ready for 6 today. Thoughts on where to begin? Other way around, but yes. Could we change cotangent to, or basically make the entire equation sines and cosines, which means changing cotangent? Okay, that is an option. I had another option in my brain on Friday too, but that is the option I've written down. So, okay, so that means we will be keeping cosine cubed x over sine x. And what do we know about cotangent according to our identities? It is the quotient identity, and it is cosine x over sine x. Okay? Other thoughts? Okay. If we want to get rid of a denominator, you need to multiply by the common denominator. We have a common denominator, yes? So we are going to take the route of multiplying both sides by sine x because it is the common denominator, and it's going to help us clear our denominators. Now, when you multiply by sine, sine as a fraction is sine over 1, yes? On the left, what happens? Okay, sine x cancels, and you're left with cosine cubed x. On the right, what happens? Sine x cancels, and you're left with cosine x, yes? Okay. This looks a little bit more like an equation that we've been dealing with. Solving thoughts? Okay. It's all cosines, isn't it? Okay. We've got all the same trig function, which is good. Compared to having 3 different trig functions, we're down to 1. So let's make it equal to 0. In order to make it equal to 0, you're going to subtract the cosine x over. And now I have cosine cubed x minus cosine x equals 0. Okay, we've done something like this before, haven't we? Both terms have a cosine. There's no third term, so it's not like we're doing product and sum. But factor out GCF of cosine. Both terms have cosines. So if I factor out GCF of cosine x, what is cosine cubed x divided by cosine x? Cosine squared, right? It's like x cubed divided by x is x squared. Cosine cubed divided by cosine x is cosine squared. Minus, what's cosine divided by cosine?
Cosine squared is
1, right? Cosine divided by cosine is minus 1. So I now have cosine x times cosine squared x minus 1 equaling to 0.
Cosine squared x minus 1 is equal to negative sin x.
Could we use a Pythagorean identity here? That is an option. Okay, and it's actually a very helpful option. There's 2 different ways we could go here. Okay, so but one option is that we do have a Pythagorean identity here. So cosine x is going to stay cosine x. Cosine squared x minus 1. Katie suggested it becomes negative sine squared x. Can we see that? Yes? And if you need to, can you sidebar and I don't know where you guys have room, but you can always think, okay, it was what? sine squared x plus cosine squared x equals 1. Well, if I'm going to make this cosine squared x minus 1, then you're going to subtract 1 over, but then you're also going to have to subtract the sine squared x over, yes? So those cancel, you have your cosine squared x minus 1 equals negative sine squared x, okay? Don't be afraid to write that out if you need to. And you may be looking at me saying, whatever, I don't need to write that out. Fine. Okay, so I now have cosine x times negative sine squared x equals 0. Thoughts? Okay. So our next step could have technically been done the last step, or it can be done this step. Either or, both will work out well, where we have two factors being multiplied together. If you have two factors being multiplied together, what do we usually do? Set them each equal to 0. Okay, let me rephrase that. You have two factors being multiplied together to equal 0, right? It only works if they have this equal 0. So we have two factors being multiplied to equal 0. Set them each equal to 0. Okay, so in both cases we would have cosine x equals 0. And then in our most recent case we have negative sine squared x equals 0. Now, interesting fact, could we have done this step a step earlier? You could have. You could have also said cosine x equals 0 or cosine squared x minus 1 equals 0. Here's the deal, they're going to work out the same. Okay, so it's all good. Now, cosine x equals 0, we're going to be ready to find answers for that one, yes? What about negative sine squared x equals 0? Okay, so you're wanting to say what?
Square rooted.
You're wanting to say square rooted. Now, the only issue with square rooting it is we have the negative. But what happens if we multiply both sides by negative? The negative disappears, doesn't it? Because then you have sine squared x. You multiply that by negative, it becomes positive. If you multiply 0 by negative, guess what? It's 0. So does that negative really matter in this case? So if it's sine squared x, you take the square root. What's the square root of sine squared x? Sine x equals square root of 0 is 0. And so we're solving two pieces here. We are solving cosine x equals 0 and sine x equals 0. Where do we find where sine and cosine values equal 0?
Create a circle.
Okay, that is looking at our quadrantals, yes? Now, this is going to be important to know what's what here. So let's see. This is 1, 0. This is 0, 1. Negative 1, 0. And 0, negative 1. And what's the order in an ordered pair?
Cosine, sine.
Cosine, sine. So when does cosine equal 0?
Pi over 2 and pi over 2.
Okay, are you guys with her? Pi over 2 and 3 pi over 2. So for that piece of this problem, we have that x equals pi over 2 and 3 pi over 2. Okay. What about sine equals 0?
Pi or 0 and pi.
Sine equals 0 is when y equals 0. That's happening at the angles 0 and pi. Are you with her? Now, we've got one different thing we've got to consider on this problem. Okay? Kind of the catch, if you will. Okay? My original problem started off as a fraction, yes? Okay. What do we know about values in a denominator? They cannot equal 0. So what was our original denominator? Sine x. So because it was in the denominator, we know that sine x cannot equal 0. Is that a fair statement? Right? Now, when we go down, so if we go back and say, okay, when does sine equal 0? Well, we technically just answered that question, didn't we? When does sine equal 0? 0 and pi. So because of that, what cannot be true? 0 and pi cannot work because plugging back into the original problem, they would not work.
Can it not equal pi? Oh, because sine x can equal 0.
Right. Okay. Because, so sine x cannot equal to 0. Where does sine equal 0? At 0 degrees and at, or 0 radians and at pi radians. Okay, so that's just a weird catch you have to watch out for. Okay, so right here, if you had used the cosine squared minus 1 equals 0, cosine squared equals 1, cosine equals plus or minus 1, you would have gotten 0 and pi, and we would have to ixnay those values. Okay, so we end up with only actually having the 2 values just because of the original problem. Okay? Questions there? Okay. Let's go down and try 7 and 8. What's different about 7 and 8? Okay, good description. It's not just x, is it? Okay, we've got a 3x or an x over 2, as Autumn said, an alteration. I don't know, something different, right? So, with that in mind, if this says sine of 3x equals 1, let's forget about the 3x for a moment. I want you to just think, okay, so just think, where does sine of x equals 1? Okay. Where does sine of x equals 1?
Pi over 2.
Agreed?
Yes.
And that's going back to our good old quadrantal, right? Where does sine equal 1? I had to pause for a moment. They're right there, yes? Pi over 2. So, a true equivalent statement is that sine of pi over 2 equals 1, correct? So here's what I'm trying to get you to think. I asked you, where does sine x equal 1? Because that's what our brains are easiest to think about. But it wasn't actually x in there, was it? But what I got you to do is I got you to say, oh, well, sine of pi over 2 equals 1. What was originally in that area, though? It wasn't x, it was 3x. Do you see where I'm going with that? Not multiply by 3, but we're going to end up dividing it by 3. So the idea is if it just said sine of x, your answer would be pi over 2. But it says sine of 3x. So basically, I'm going to suggest that we take 3x and set it equal to pi over 2. Because we want to know, when does sine of 3x equal 1? Well, we know sine of pi over 2 equals 1. So basically, take the 3x and set it equal to pi over 2. How do you solve that? Divide by 3, which is also multiplying by 1/3. And I'm saying multiply by 1/3 because I'm looking at this fraction on the right. So when I multiply 1/3 of 3, that leaves me with x. What's pi over 2 times 1/3? Pi over 6. Okay. You don't see a lot of these in homework by any means, but again, trying to get your brains thinking a little differently here. When that x is not just an x, when your variable is not just an x. Okay, come up with what x would be, and then set it equal to what that altered x is. Okay? So let's look at 8. 2 cosine of x over 2 equals negative square root of 2 over 2. What do we need to do first?
Add the negative square root of 2 over 2.
No. I'm not going to think yet. I want to get the cosine by itself. Okay, because I can get it to just be cosine of something equals something, I'm going to get cosine by itself. So we're going to divide by 2. And I'm going to have the statement cosine of x over 2 equals negative square root of 2 over 2. Okay. Now that I have cosine of something, now I'm ready to think, if you will. However you want to put it. But that was my way of, trying to get us to equivalent. So we're going to think, where does cosine of x equal negative square root of 2 over 2?
Negative pi over 4.
So, okay, how do I want to take us here? According to your chart, forget the negative, where does cosine equal square root of 2 over 2? Everyone there? So it's pi over 4 in quadrant 1. But what's the catch here? We're being asked negative. Do I want to look at quadrant 1? No. Well, we want to look at any place cosine is negative. So all students take calculus. So where are we looking? We're going to be looking in quadrants 2 and 3. And we're going to be looking, because that's where cosine is negative, and we're going to be looking for the equivalent pi over 4 angle. What's my equivalent pi over 4 angle? In quadrant 2, it's 3 pi over 4. In quadrant 3, it's 5 pi over 4. Are you with me? And so what I'm looking at here is that, how do I want to write this? This isn't good writing, but cosine of, I'm going to put 3 pi over 4, comma 5 pi over 4. Not good writing. But do you see the visual you need to see? Okay. Where does cosine of x equal negative square root of 2 over 2? Well, it happened at 3 pi over 4 and 5 pi over 4. Yes? What were those put in place of? X over 2. So x over 2 equals what? 3 pi over 4, and x over 2 equals 5 pi over 4. Or set up as one equation. I don't care. How do we solve? Try again. Since it's x divided by 2, I'm going to multiply by 2. 2 can become 2 over 1, yes? What do we get?
3 pi over 2. 10 pi over 4, 6 pi over 4. Do you want them? Because you could simplify.
Reduce if you can, yes. So if we multiply 3 pi over 4 times 2 over 1, that is 6 pi over 4. But 6 pi over 4 reduces to 3 pi over 2. Or I would have cross-canceled the 2 and 4, become 1 and 2, so 3 pi over 2. So 5 pi over 2 over 5 pi over 4 times 2 does become 10 pi over 4, but it reduces to be 5 pi over 2. So you actually get two answers there. Okay, guys. Your job is to attempt the ones in homework, yes? It is an attempt. I'm not going to argue. Okay? But every single problem should be written down and have an attempt on it. Not just written down of, oh, I wrote it down. But, put some brain thought into it. Okay? And then tomorrow, my main plan is to talk questions. Okay? I mean, I don't know if it'll take the whole period or not, but if it does, it does. But I need you before tomorrow to put the effort into attempting all of them, right? Because me guiding you through them, yes, that is great, but you've got to learn to guide yourself.